Okay, so we'll be looking at this question. This question is a question from 2006 paper 1 question 21. Okay, let's read the question first. Three students stands 2 meters apart in front of a plane mirror that is 3 meters long. Student Y is standing opposite the midpoint of the mirror. How many students can see the images of the other two? So this question is a question on reflection, and in order to answer this question, the first thing we need to know is first we need to revisit the properties of a mirror image. So here are some of the properties of the mirror image, the 5 properties: same size, laterally inverted, virtual upright, and same distance behind as the object is in front. The most important property that will help us answer this question is actually the 5th one, right? So why is it so? I'll explain in the next information. So first of all is this. Okay, for a mirror image, we must first know that light rays always travel in a straight line. This is something you need to remember. So what happens is that when an image is formed in a mirror, the image gives the observer an impression that the light is traveling straight from the image to the observer. So that means that if we are looking into a mirror, we see the image because it seems to us that the light ray is traveling from the image to us. So and also that the light ray seems to travel in a straight line from the image to us. So these are the two things you need to know. First, light ray travel in a straight line. Secondly, that's the light rays seem to travel in a straight line from the image to us. So there are 3 steps to consider when you are answering such a reflection question. Is number 1, locate and draw the image. Okay. Number 2, draw light rays from the image straight to the observer. And number 3, all the rays that are drawn must cut the mirror. If the rays are outside the mirror, it will not be possible. It will not be a possible ray because reflection need to take place on the mirror. Alright, so these are the 3 rules that you need to take note. So with this information, let's start. So the first thing you need to do is that you need to draw the image of the 3 students. So the first student will be student Y. Okay, so you measure this, which is about 1.5 cm. So since we know that the first rule is that the image is exactly the same distance behind the mirror as the object, so it will be 1.5 cm above. Similarly for this, it will be 1.5 cm above and 1.5 cm above. So the next thing you need to do is to draw the light ray, okay, from the image to the observer. So this is x prime, y prime, and z prime. Okay, so let's start with x. So for x, student X, right, he will be able to shine a ray straight to student Y, and student Z. So because the rays cuts the mirror, so that means that student Y and student Z can see student X, right? Then how about student X? Can he see himself? No, because the ray will actually go straight through, and this ray will not cut the mirror because it's out of the range. Now how about student Y? Student Y will be able to be seen by student X, student Y himself, as well as student Z. Right. So student Y will be able to see 3 students, himself and the other 2. How about student Z? Student Z is similar to student X. Okay. Student Z will be able to be seen by student X as well as student Y, but not himself because it's out of the mirror again. So let's look at the question again. How many students can see the image of the other 2? So since student X can see student Y and Z, student Y can see 3, So Z can see X and Y. So the answer is all three can see each other. So that's how you solve for this question. Okay, that's all. Thank you.